In this project, I'll be talking about the 2018 movie budgets and box office earnings. I'll be using the top 100 grossing movies to find out how the movie's budget affects the performance, either in a positive or negative way. I'll also be figuring out if the year the movie was made affects the gross profit. All the data comes from Numbers.com and was last updated in 2018. Here's the bar plot histogram. The mean is 170.022. The median is 175. The mode is 200. The standard deviation is 73.46. The IQR is 75 and the range is 414.5. The summary talks about the skewness, and also, if you can look at the bar plot, it shows that it is mostly skewed right. The scatter plot shows the relationship between the budget and the domestic gross, as you can see from the data. This is the measure of center interpretation. The scatter plot shows the relationship between the budget, X, and the domestic gross, M. The graph corresponds to the idea that the higher the budget, the higher the domestic gross. The center of scatter plot is located at 170 million and 351 million. The median for the scatter plot is located at 175 million and 332 million, which is basically the midpoint between the highest and lowest value. The mode in the dataset is 200 million, meaning that the movie budget of 200 million appeared most frequently. There is no mode for the domestic gross, meaning that no same movie made the exact same profit. So for the conclusion, the skewness of 0.614 means that the data is clustered in the lower to middle range, with a few higher budget films stretching the distribution to the right, which basically means that the higher budget films are causing the skewness to the right because of how much higher they are than the rest. For the domestic gross data, the skew is 1.689. This means there is a strong positive right skew, showing that most movies make lower profit, while some blockbuster films causing a more dramatic right skew. Overall, this shows that extreme high earning movies are more common than extremely high budgets. This is the box plot. The box plot shows the relationship between the budget and the worldwide gross. The measure of spread. Standard deviation shows how far movie budgets and worldwide gross fall from their average values. The budget standard deviation of 73.46 million shows that for most movies typically vary around 170 million by about 73 million, either higher or lower. For worldwide gross, the standard deviation is 316.07, which means that the movies vary about 316 million, either higher or lower, from the worldwide average of 977 million. The IQR represents the spread of the middle 50% of the data. The IQR of 75 million for budgets mean that the middle of half of movie budgets fall within a 75 million range, while the IQR of 245 million for the worldwide gross shows that the typical movie middle groups of movies have a very wide range of earnings. The range shows that the total spread from the smallest to largest value. A budget of 414.5 million means that the difference between the cheapest and most expensive movies is over 400 million, while the worldwide gross of 2.08646 million highlights how massive the gap is between the lowest and highest grossing movies worldwide. These measures show that both budget and worldwide gross earnings have a large amount of variability. Here is the correlation and regression. The budget is X, the worldwide gross is Y. R is equal to negative 0.075. The least squares regression line is is 1237.40 plus negative 13x. The slope is 0.13 negative. R2 is 0.0056. And here's the relationship. The relationship between the worldwide gross and budget is very weak, with the correlation coefficient being negative 0.075. Most points are scattered to where there is no upward or downward movement, showing that higher movie budgets do not always mean higher earnings. The data also has a negative slope of negative 0.13, which means every $1 million spent, the worldwide gross decreases by $0.13 million. The coefficient of determination, 0.0056, indicates that only 0.56% of the variation in worldwide gross is determined by budget. This shows that budget is unable to accurately predict the worldwide gross. These factors show that there is no reliable proof in this dataset that the positive relationship between movie budget and worldwide gross. Prediction. I predict that using the linear regression equation 1237.40 plus a negative 0.13x, I can predict that spending an additional $1 million on a movie would cause an approximately $130,000 decrease in worldwide gross profit on the movie. My probability question is, what is the probability that a movie in this dataset will be made in December between 2000 and 2010? The probability that this happens is 3.9%. The probability that the movie was made between 2000 and 2010 is 0.30. The probability it was made in December is 0.13. So you take those two numbers and you multiply them together, which gets 0.039. Move the two decimal points, which gets you to 3.9%. I also have two budgeting questions, but I'm only going to talk about one. What is the probability that a movie with a budget of $200 million or higher made $1 million or higher in worldwide gross? The probability that this happens is 11.84%. The probability that budget was higher or equal to $200 million was 0.37, and the probability that one of the movies made was higher than $1 million in worldwide gross profit was 0.32. Take those two numbers and you multiply them together. Here is the relationship for the probability distribution between budget and P probability. 0 to 100 is shown to be 0.19. 100 to 200 million for budget is shown to be 0.44. 200 to 300 would be 0.31. 300 to 400, 0.04. 400 to 500, 0.02. Here is the probability distribution graph. It is shown that it is skewed right. Here's the inferential statistics for the mean. Hypothesis number 1 is the mean number for budget of the top 100 movies less than 200 million. We are 95% confident that the mean budget is between 155.45 million and 184.6 million. We do have strong enough evidence that the mean budget number for the top 100 movies is less than 200 million. This is shown by the p-value being less than 0 or greater than or less than 0.0001. We rejected the null hypothesis because the p-value was far less than 0.05, which is the significance level. The mean budget of 200 million is not supported by the sample data. Here is the inferential statistics for proportion. Hypothesis number 2 is the proportion of the top 100 movies with a budget less than 200 million greater than 50%. We can say we are 95% confident that the proportion of the top 100 movies with a budget greater than 200 million is between 0.54 and 0.73. The confidence interval is about 50%, so there is enough evidence to show that the proportion of the top 100 movies with a budget less than 200 million is greater than 50%. Since the p-value 0.0047 is less than the levels of significance of 0.05, we can reject the null hypothesis. There is sufficient evidence to conclude that more than 50% of the top 100 movies have a budget less than 200 million. This concludes my presentation on the top 100 movie budgets and box office earnings for worldwide gross and all the relationships shown in the graphs and the studies that we did.